Is this podcasted?
I'm sure the room is podcasted.
Does that mean everything we're going to say is going to be nothing?
So there's no big mics.
I mean, I still think it's
Yeah.
Question 5 is like, fragmented, write down all possible signs of precise. Like, I've done a line and I've done just all of them stuff.
Oh wait, no. There. I found 10. Because the order doesn't matter. So if there's 13 and 7 and 9, then you can ignore the one that's 7 and 3.
It's not a presentation, it's a conversation. Well, it's like if it's people, if you're asking two people their opinions, it doesn't matter which one's their opinion.
So on 379, 397, so there was
That's the knowledge.
Yeah. Let's just look on the first, on the first couple of ones.
You done question 1, guys. Question 1 is pretty it's trivial. Listen, guys. All right, question 1. So which of these 5 cases is representative or constitutes a representative sample? This is the first case is not representative because not everybody likes football games. Not everyone. Likes football, right? So it will not be a representative sample. Number 2, is it representative or not? No, not representative. Because not everyone right? Not everyone can afford an expensive town, or to live in an expensive town, or to go to shopping in an expensive town. Number 3, is it representative or no? Huh? It is representative, right? because you're just taking names out of the water roll, so it's purely representative. Number 4, yes or no? No. Not representative. Because not everyone has a TV, not Number 5, is it? No. It's for the same reason, not everyone has a phone. Alright guys, this is clear to all of you. This is question 1, done. Can you do question 2 please? Unless you have question. Can you do question 2 please now?
Oh, that's on my paper.
Question 3, considering all possible samples, calculate any awareness. Is that different to calculating part 1 and 2? Oh, wait 1 sec.
Yeah, that's what I was not sure about, because in the notes that he's given us a formula for calculating the sample mean and the variance, except it didn't give you the right answer. I don't quite understand why. Because it's the first one, the population means that you use all of them, and the second one's a sample of 2. But does that mean we have to write down all the different,
I think so.
all the different possible samples? Yeah.
Everybody down question 2 guys.
Yes or no?
Right. Alright, question 2 is the same, it's similar to question 1. So there are 3 parts. Alright, is it representative or not? Part 1.
No.
Not representative. Because not everyone. Number 2, is it representative or not? Right, because people are not likely to say what the income is, like when you have a group of people around, they are not likely to say what the income is. Number 3, is representative or not? No, why? It's not representative because the question is misleading. Right, because when you ask a question like this, whether something is unfair, people are likely to say the opposite, right? Not likely to say the opposite. So they will say yes to something. You know? So alright guys, are you okay with this or not? Can you do the next one?
Yeah, the register's just done.
Oh, they're going to come outside. Just turn them off, those feel nothing.
I don't understand question 4. Does it mean increasing the sample size? It could be, or is it just...
You're right. Yeah, we are doing question 3 now. Question 3. Yeah.
Is there a separate on the black notes?
Yeah, there is, but it's in the lecture notes. It says you have what n is, and
It's N's 2, isn't it?
is it still 2, or is it meaning n could be anything now? Oh no, n is still 2. Yeah.
Okay, let me start. Let me start on question 3. No, I mean, The question 3 is the first two parts are not difficult at all. So you should just get through that. Question 3. So the population in this case is a set containing the numbers 2, 3, 6, 8, and 11. Right? The first part is to calculate the population mean. So because you are sampling without with replacement, each has a probability of 1/5, right? So the mean is simply 2 times 1/5 plus 3 times 1/5 up to all the way up to 11 times 1/5. So this is the formula that I gave you last week, if you recall what we did last week. Right, this is using one of the formulas I gave you last week, right? So the answer is 6. So that's the mean. And the second part is to find the variance. To find the variance, first you need to find the expectation of x squared, which is going to be 2 squared times 1/5 plus 3 squared times 1/5 up to 11 squared times 1/5, which if you compute this, you will get 234 divided by 5. Alright? So the variance is this, which is going to be 234 divided by 5 minus 6 squared, which is 36. And if you work this out, it will be 10.8. Okay? So what you got guys, right? Okay, now the third part is, it requires a little bit of thing. It's not so straightforward, but because here you're looking at the mean and the variance of the sampling distribution of x bar. I talked about this briefly last week, if you remember, in the lectures. Now, when you do without replacement, right, what are the possible outcomes can you have? You can have 2 is a possible outcome, right? You can have 2, 3, 2, 6, 2, 8, 2, 11, right? These are possible. And what other possible outcomes can you have? You can have 3, let me put it here, 3, 2. You can have 3, 3. You can have 3, 6, 3, 8, 3, 11. Right? You can have 6, 6, 2, 6, 3, 6, 6, 6. Oh man, sorry. Sorry guys. 6, 8, 6, 11. Alright, and you can have also 8, 8, 2, 8, 3, 8, 6, 8, 8, and 8, 11. Right? And finally, you'll have 11, 2, 11, 3, 11, 6, 11, 8, 11, 11. Now these are all the possible outcomes that you can have. Now the question is to find the sampling distribution of x bar. So the first thing you must do is to find the value of x. Remember, x bar is the sample mean, right? You need to find the value of x bar for each of these outcomes. So that you know how to do it. So what you do is you just compute the, okay, let me use a different color. The average for this is 2.5. This is 2.5, 4, 5, 6.5, 2.5, 3, 4.5, 5.5, 7, 4, 4.5, 6, 7, 8.5, 5, 5.5, 7, 8, 9.5, 6.5, 7, 8.5, 9.5, and 11. Alright, you see, so the things in red are the averages. So in other words, the value of x bar corresponding to each outcome, right? Alright, so the next thing to do, guys, is to construct a table of the probability distribution of x bar, right? Now, what I mean by that is, alright, let me take this up. Alright. You need first determine the values for the possible values for x bar and the possible the probabilities, the corresponding probabilities. So this is going to be like a table. Now, if you look at the numbers that I marked in red, what are the possible values x bar can take? It can take the value 2, 2.5, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, 9.5, and 11. So these are the possible. Do you see how it come across these? These are the possible values x bar can take. And for each of these, there are corresponding probabilities. Because, for example, when x bar is 2, how many of these outcomes have x bar equal to 2? How many there are? 1. All right. So the corresponding probability will be like this. Let me put this here. So for x bar is 2, you have 1 out of 25. There are 25 outcomes in total. And there is only one outcome, 1 out of 25 that has x bar equal to 2. And 2.5, there are 2. There are 2 outcomes out of 25 with x bar equal to 2. 3.3, you have 1. 4, you have 2. 4.5, you have 2. 5, you have 2. 5.5, you have 2. 6, you have 1. 6.5, you have 2. 7, you have 4. 4 outcomes with x bar equal to 7. 8, you have 1. 8.5, you have 2. 9.5, 2. And finally, 11 has only 1. So this table here gives the probability distribution of the x bar, right? Now the question is to find the mean and the variance. So you should know how to do that. So the mean is gonna be just use the formula that I gave you last week, all right? You just multiply this column with this column. That's it. So 2 multiplied by 1 over 25, 2.5 multiplied by 2 over 25, and all the way up to 11 multiplied by 1 over 25. Right. So the answer will be 6. It's a coincidence that the expectation of x bar is also 6. Right. And the variance of x bar, okay, to find the variance you need to find this first, right? So this is going to be 2 squared right. This is the expectation of x bar squared, which if you work it out will take me forever. I'm just writing down the answer, right? So therefore the variance of x bar which is simply this minus the square of this right? It's going to be 41.4 minus 6 squared, which is 36. So this is equal to 5 point. Alright guys, so this is how you do part 3 of question 3, right? Is that okay? Any questions, guys? Yeah? You alright guys? Can you do question 4? This is question 3. Can you do question 4 now, please? Question 4 is similar, I think. Well, question 4 is the continuation of question 3, so you should know. You should know what to do. All of you guys sign the attendance sheet. If you haven't, let me know. You all signed, sir. Guys, you should have done quiz 2 and wants to hand in now, if you can do so. It will save me time because I don't want everybody to hand in their quiz on Monday. I will not have much time. You know what I'm saying? Yeah.
Yeah.
Where's your ID, sir? Can you write your ID, sir? ID number. Yes.
I have a question about the quiz 2.
Yeah.
I got to this point, and then I couldn't work out how to integrate that. So I looked it up.
No, you don't need to know how to integrate. because you should look at this, ma'am. This is like a normal density of a normal distribution, right? I mean, this is part of a density of a normal distribution.
Yeah.
Yes? And you know that any density must integrate to 1. So try to use that fact. Try to use that fact.
What do you
You know,
mean?
any density must integrate to 1, right? So the density of the normal should integrate to 1.
What do you mean by the density?
The density of the normal,
Oh, right, yeah,
you know,
okay.
density of the normal
Yeah.
distribution, which is 1 over square root of 2 pi, and all that,
Yeah.
should integrate to 1. So you should try to use that fact. You don't need to know. What I'm saying to you, ma'am, is that you don't need to know how to integrate this.
Okay.
It's not easy, but
No.
try to, but to integrate this, just use the fact that the normal PDF integrates to 1. You should know. Okay. Anyway, I'm sure you will work it out.
I think it needs to start with pull this out.
Yeah.
I think if you leave that in, well, because when you pull it out, it cancels it out. Not when you integrate that, when you pull it out, but if you leave that in, you just pull these out as you go, and you get the same.
All right, guys. Question 4 is the same as question 3, except that you're doing sampling without replacement, right? So the possible outcomes are going to be different, right? So what are the possible outcomes? You can have 2, 3. This is one possible. 2, 6, 2, 8, 2, 11. Okay, you can have 3, 3, 6, 3, 8, 3, 11. Right? You can have 4. So there's no 4. Sorry, there's no 4 here. Sorry, so you can have 6, 8, 6, 11. Right? And any other outcomes?
8, 11.
8, 11, yeah. And you can have 8, 11. Alright, the next thing to do is to find the averages for each of these outcomes. This is 2.5, 4, 5, 6.5, 4.5, 5.5, 7, 8.5, and 9.5. All right, so the red marks the average, the value for x bar, right? Now I'm going to do the table like what I did last time. So a column for x bar and a column for the probability that x bar equals to equal x bar, right? The possible values for x bar are 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, 9.5. Right, these are the possible values. And the corresponding probabilities for 2.5, there are 10 outcomes in total. If you look over here, guys, there are 10 outcomes, and there's only one outcome that has x bar equal to 2.5. So it's 1 divided by 10. For 4, it is 4.5, also 1 divided by 10. 5, also 1 divided by 10. 5.5, 1 divided by 10. 6.5, 1 divided by 10. 7, 2 divided by 10. 8.5, 1 divided by 10, and finally 9, 1 divided by 10. So this table gives the probability distribution of x bar. So to compute the expected value of x bar and the variance is trivial. Okay, so you just Alright, this is the expected value. If you work this out, by coincidence, this is also equal to 6. Alright? To find the variance, you need to find the expectation of the square of x bar, which is 2.5 squared right, and this, if you work it out, will be 40.05. Alright, so the variance of x bar is simply 40.05 minus 36, which is 4.05. Alright, so that concludes question 4. Is that right? So you can see that the sampling without replacement is more efficient than sampling with replacement. The reason being because the variance for sampling without replacement is small, is 4.05, which is smaller than the variance for the sampling with replacement, which was, I think it was 5.4 or something. So the smaller the variance, the more efficient the scheme is. Right? So this sampling without replacement produces a smaller variance and therefore more efficient than the sampling with replacement. Right? Alright guys, any questions? Can you do question 5? Yes.
I was going to start with divided by 20 and I got stuck.
You got what?
And for the expectation, I divided by 20 instead of 20. I got 6.
Why is it 20? Can you guys do question 5 please now? This is okay with everyone. Any questions on this? Yeah? And you guys do, are you guys okay with this?
Yeah.
Yeah. Can you guys do question 5 please? You have a question? You can do
Have you done 5-part III?
That's another one.
No, I don't know how you're finding the mean of the sampling distribution of the sample mean. So,
You're right. Oh, you're done. Good, good. Thank you, man.
Yeah, she's in, when we were doing second class, she was saying it should come out to 1. Yeah, like the PDF. I think because we pulled out a bit at the start, that should still be inside and then that'll be equal 1.
All right, let's see question 5. You Russell, okay? Good. Right, let's see how we can do question 5, guys. Question 5 is similar to what we did so far. All right, you have a population with, the population consists of the following numbers: 3, 7, 9, 11, and 15. Right? Right. The first thing we want to find is the population mean. The population mean, the expectation of x, right, is you know the formula, right? Is so if you multiply each number by the probability, if they are equally probable, so the probability is 1/5. Right, and if you work this out, you will get 409. I think the answer is 9. Right? Part 2. Write down all the sampling schemes. Samples. When you do it without replacement. Right? So you're picking. You're picking numbers, 3 of them, right? And you're picking them without replacement. So the possible outcomes can be as follows. The outcomes are as follows. You get 3, 7, 9. This is one possibility. You can have 3, 7, 11. 3, 7, 15, 3, 9, 11, 3, 9, 15, 3, 11, 15, 7, 9, 11, 7, 9, 15, 7, 11, 15. And finally 9, 11, 15. Alright, the next thing you need to do is to compute the sample mean, because the question is to find the sampling distribution, right? So the sample mean is going to be as follows. Let me use the red pen. So the first pair, the sample mean is 19 divided by 3. Oh, am I on the right track? 9, 21, 25, 20, oh, sorry, man. I don't know how to add things. 23, 27, 29, this is 29, 20, 27, 27, 31, I'm sorry about this, guys. 33 divided by 3, and finally 35 divided by 3. Right? This is, I'm sorry about this, this is 29. Alright? So these are the means. Now to compute the averages, right? So to compute the expectation of x bar, you just, because each of them are distinct, right? There's nothing in common. Each has a probability of occurring with 1/10. So it's gonna be 19 by 3 multiplied by the probability, 21 by 3 multiplied by the probability, up to 35 by 3 multiplied by the probability, which is 1/10. There are 10 outcomes, each is equally probable. Alright, so if you work this out, you will get, once again, expectation to be 9. Expectation of x bar squared is this. Right, and this will work out to be 83.667. Right, therefore the variance of x bar is 83.667 minus 9 squared, which is 2.667. Alright, so that completes part 2. Now part 3 is the same, but here we don't want to compute the sample mean, but the sample median. All of you guys know what the sample median is by now. Right, so I know we are running out of time. Just bear with me, guys. I also haven't had my lunch yet, so just wait. Just bear with me. Part 3. Right, I want to rewrite the pairs one more time. 3, 7, 9, 3, 7, 11, 3, 7, 15. 3, 9, 11, 3, 9, 15, 3, 11, 15, 7, 9, 11, Alright, these are the outcomes once again. The medians, I'm sure all of you know by now what the median is. So the first one it is 7, 7, 7, 9, 9, 11, 9, 9, 11, 11. Alright, so these are the medians. Right, so the expectation of expectation of the median, right, is as follows. It will be, because if you work out the expectation, I'm not going to do it. It's going to be 9. You know how to do it, right? And the expectation of the square of the median will be 83.4, and therefore the variance of the median will be 83.4 minus 9 squared, which is 81. So it's 2.4. Right. So this completes question 4. Right. And for the last part, it's asking you which is more efficient. If you compare 2.4 with 2.667, the median is more efficient. The median is more efficient because because it has smaller variance, right? The variance under the median is 2.4. The variance under the sample mean is 2.667. So this is more. Alright guys, I'll see you guys next week. If you have any questions, you know where to see me. Yeah, I'll meet you there.
Oh yeah, ours is still on Friday. Yeah. I'd rather be nice. I'll finish Friday early, yeah.
But then I just got an hour gap.
Hello. Thank you, man. Thank you, man. Hello. I'll put another class now, but after the class I will leave it with Tracy.
Yeah, I was just going to say, can I get a copy of these now as well?
Yeah, I will. I will print everything I have. I will scan this and upload them. Okay. Yeah. All right. Thank you, man. Have a good day.
Handing out fantastic. I've worked it out, I've integrated it by putting out all of the content outside, and then I ended up doing e to minus v squared over 2. And I know that you said today the normal distribution is 1 over 2 pi e to so does that mean that that and that is not 1? So if I take out that, then that has to be equal to the square root of 2 pi. Yeah. So then them two will cancel, and then I just left with that. Okay, thank you.
You done, sir?
No.
You haven't done it? Okay. Hello, you alright?
Yes,
You have a question?
If I say that you have to have a telephone, then I can say that it is a
Yeah, but not everybody has a telephone. So, not in the UK it's okay, but like in some countries, a lot of people don't have telephone. Yeah, thank you, sir.
I see that in the UK also.
Yeah, thank you. Yeah. See you guys. Have a good day. You're right, sir. You got any course here? What course are you taking?
Actual science.
You like it?